Hello, everyone, and welcome. My name is Replacement. I'm a senior principal at Geosyntec Consultants in Oakland, California. I'm the coordinator of the webinar series on behalf of SERDP and ESTCP. I have the pleasure of facilitating today's event. This webinar focuses on federally funded research efforts to increase energy efficiency at DoD installations. The webinar will feature two speakers. First, Mr. Brian Urban from Fraunhofer USA Center for Manufacturing Innovation will talk about his team's efforts to retrofit DoD installations with LED lighting controls to significantly reduce energy usage. Second, Mr. John Schlechter from the Mechanic Technology Company will talk about his team's work to demonstrate the effectiveness of insulating secondary window attachments at reducing energy loss also at DoD installations. Each presentation will be followed by a Q&A session, and we will conclude the webinar with a longer Q&A session. The next several slides provide instructions on optimizing your webinar experience. If you have not done so already, please download Zoom at the link shown here and provide it to you in your webinar registration confirmation email. If you cannot download Zoom, you may view the slides using a compatible internet browser, such as Firefox, IE, or Edge, and by creating a free Zoom account. If you're unable to view the slides, or if your screen freezes, try keying in Control and F5 to perform a hard refresh of your screen. If you're accessing the audio through your computer, click the arrow next to the Join Audio button, select Test Speaker and Microphone, and follow the prompt as they appear on your screen. If you continue to experience difficulties, please call into the conference line shown here. You may also submit a comment using the chat box. Please use the chat box only for comments related to technical difficulties. The Q&A option should be reserved for questions for the speakers. And in case of continued technical difficulties, just download a PDF of the slides from the webinar webpage and call into the conference line provided to you in your webinar registration confirmation email. Another viewing option is to go to the SERDP and ESTCP YouTube channel at the link shown here, as we will be live streaming the webinar on that channel. Note that today's broadcast will be listen only. You can submit questions using the Q&A box on your screen. Please don't wait until the Q&A period to get your questions in. We encourage you to submit them as you think of them. And when you submit your questions, please add your organization name at the end of the question so that we can identify you during the Q&A session. With that, I would like to introduce Mr. Timothy Tetro, who is the ESTCP Program Manager for Installation Energy and Water. Before joining SERDP and ESTCP, Tim worked at the National Renewable Energy Lab, where he focused on energy efficiency and renewable energy project development for the federal sector. Tim, please proceed.
Thank you, Rula, and welcome everybody to today's SERDP ESTCP webinar. Got a few slides here to provide an overview of the program, SERDP and ESTCP, and then I'll hand it back to Rula to introduce the presenters for today. SERDP is the Strategic Environmental Research and Development Program. It was established in 1991 by Congress as a partnership between DoD, the Department of Energy, and EPA. SERDP's mission is to identify and address high priority environmental science and technology opportunities that focus on DoD requirements. And SERDP funds both fundamental research as well as advanced technology development that ultimately impact real-world environmental management. ESTCP is the Environmental Security Technology Certification Program in which we demonstrate innovative environmental and energy technologies. These investments capitalize on past investments under SERDP or other research programs and are designed to transition technologies out of the lab and into the field. Especially important in all ESTCP demonstrations is the ultimate transition to implementation and regulatory acceptance. SERDP and ESTCP are complementary programs with much of SERDP research occurring in the lab and pilot scale with occasional field efforts, while ESTCP demonstrations are primarily at the pilot and field scale, although occasionally some supporting lab efforts are conducted. There are several environmental and energy-related drivers for the type of work funded by SERDP and ESTCP, with the underlying objective of sustaining DoD ranges, facilities, and operations. This is a broad undertaking, as you can imagine, and it takes the form of looking at energy efficiency and energy resilience, maritime sustainability, threatened and endangered species, climate impacts, unexploded ordnance and munitions constituents, as well as other environmental drivers. One of the key environmental drivers is the reduction of current and future environmental liabilities. This involves addressing contamination from past practices, including impacts to groundwater and soils and sediments, UXO contamination, and developing management approaches for contaminants of emerging concern. The second part of this is pollution prevention, with a focus on eliminating chemicals of concern or hazardous materials in manufacturing, maintenance, and operations of our installations, as well as improving the energy efficiency of our facilities and operations. We have several main focus areas of research and demonstration at SERDP and ESTCP, all shown here. This is a sample. We have others as well. And as I mentioned earlier, technology transfer is particularly important within SERDP and ESTCP programs. Technology transfer efforts include the development of videos, training workshops, and guidance documents. The webinar series is a substantial component of our overall technology transfer efforts. Our webinar series highlights research and demonstration efforts from all of our program areas. And upcoming topics include the effects of phenology on species management, concerns on DoD lands, removal of munitions constituents from wastewater, excuse me, developing and demonstrating PFAS, passive samplers, and others. And registration is open for webinars throughout the end of this year. You can find additional information about upcoming webinars at this link, and all past webinars are archived and can be accessed also at this link. Also want to highlight that we have the 2023 Symposium coming up. Will be held between November 28th and December 1st in Arlington, Virginia. And abstract submissions for poster presentations is now open, and those submissions are due by Sunday, August 6th. And finally, I'd like to remind you that a copy of the presentation of today's session can be downloaded from our webinar page. And we would appreciate if you can take a moment after the presentation to complete a survey that will pop up on your screen. With that, I hope you enjoyed today's webinar, and I'll hand it back to Rula to introduce our speakers.
Thank you, Tim. It is now my pleasure to introduce our first speaker today, Mr. Brian Urban. Brian is a senior engineer at the Fraunhofer USA Center for Manufacturing Innovation in Boston, Massachusetts. He has more than 15 years of experience in applied research related to building technology, energy systems, and cybersecurity. He has served as a PI on several ESTCP installation energy and water demonstrations, including an HVAC analytics platform, cybersecurity tools for facility-related control systems, and an award-winning wireless lighting controls retrofit for high bay applications. Brian received a bachelor's degree from Cornell University and a master's degree from MIT, both in mechanical engineering. Brian, we're delighted to have you. Please get us started.
Thank you, Rula, and thanks, Tim. Welcome, everyone. My name is Brian, again with Fraunhofer USA. We are a nonprofit R&D group in Boston, and we evaluate emerging energy technologies. Today, we're here to talk about wireless LED controls for some high bay DoD lighting applications. And you may be wondering, why are we focused on LEDs and controls? Aren't these technologies well established? Haven't they been around for a long time? Well, the truth is that they have, but they haven't been adopted so much within the DoD and within commercial buildings at large. And some really cool advances in recent technology, we think, can change that. So the point of this demonstration was to kind of bust some of the myths or misconceptions about wireless controls and LEDs in DoD facilities and show how these tools can be a real practical way to both improve the lighting conditions while also reducing energy consumption in major DoD facilities. So that's kind of the setup. For today's talk, we are going to focus on a couple of different areas. Just one second. There we go. Yeah, so we'll start with a project overview. We'll describe the technology. We'll get into some site descriptions and project results, and then cover some of the lessons learned along the way. Just as a caveat, I am not a lighting designer, and I had never before done a military construction project. So I think if I could do this, either it was beginner's luck, or I think more likely you all could do the same thing, if not better. So really, if you remember one thing, that this stuff isn't as hard as it might seem. And so I encourage all of you to consider this as a technology as you do your lighting projects. But to start, many of you know LEDs can cut lighting power way down, typically in half versus the status quo lighting systems. They last longer, they're brighter, they work better. But if you only do LEDs, you're really missing a huge opportunity. Controls can typically save an additional 50% over the existing LED power reductions, and automated controls can make that really easy. In this example here, you might start with a metal halide fixture. Cutting to LEDs for the same brightness could bring you down to about 200 watts, or cutting the power in half. And then if you apply just one simple control strategy where you trim the lights to match the target, you could save another 20 or 30% without doing any fancy controls, just very simple controls. So we think with advanced control systems, you can get more flexibility and a lot greater benefit, which we're going to cover today. When we talk about smart controls, LEDs with integrated smart controls can save over 80%, and that's what we found in this study. Integrating the LEDs with the controls can reduce the first cost of the system and provide better performance. You don't have to worry about compatibility of aftermarket controls. It's simpler to install. You have granular control if it's fully integrated, so you get better performance. You can adjust the brightness later on. You can improve the LED lifespan, and you can get a bunch of tracking data for occupancy or energy usage within your facility. So tons of new opportunities and new data streams. For this particular project, we focused on three main control actions or activities. The first is task trim, which we just talked about, where you install new lights, but they're typically too bright for the application. So you can cut down the high end by 20% or more to match a target. In the second case, many of you have seen daylight dimming. This is where the lights don't have to work as hard if you have sunlight through windows or skylights or things like that. And then finally, occupancy control. And again, I think most of you have been in rooms where the lights will turn off when nobody's around. So with these three strategies layered together, plus the LED efficiency, you can save over 80% on your lighting energy needs. And it's a real opportunity for the DoD to make some strides. So for the project, this was a multi-year demonstration. We measured the existing lighting system for over a year, and then retrofit the lights, and then measured the performance afterwards for energy and cost savings, again, targeting 60 to 80%. Looking for a fast payback, more light, easy installation, and satisfied users. So those were the metrics, and sort of to keep a long story short, we met all the key objectives, and the technology worked really well. The lighting partner here was Digital Lumens. They are a US-based manufacturer of advanced connected lighting systems, and our host site was Westover Air Reserve Base in Chicopee, Massachusetts. So a big shout out to the team there, Wayne, Mark, Miguel, and everyone at Westover really helped make this project a really great success. Okay, but let's get into the technology. So first, you start out with the smart LED fixtures. These are LED fixtures with integrated sensors and wireless controls. So you might have hundreds of these in a facility, and they talk wirelessly to gateway devices that you put on the ceiling of the different rooms or the different zones. So you might have, 5 or 10 of these gateways. They look like wireless routers, but they speak a different protocol for industrial control systems. And then those gateways are wired through Ethernet cable back to a controls appliance that you would typically put in an electrical room or a utility closet. And that device provides the coordinated control for the lighting system. So there's really just these 3 main components, and it's not all that complicated. This is for this particular lighting system. There are many other variations or flavors of this from different vendors. So the results here are illustrative, but again, things work pretty well. If we go a step further and look at the lights, they come with dimmable LED light bars. They can dim from 0 to 100%. Each fixture has its own built-in sensor module that can measure occupancy using a passive infrared sensor, illuminance to measure daylight. It basically looks at the ground and measures how bright the ground is beneath the fixture. And then some of them have onboard energy metering capabilities where they'll measure their own self-consumption and report it back to a dashboard so you can keep track of the savings over time. Again, all of that goes over an encrypted Zigbee wireless mesh network. The lights talk to each other and then back to the home base appliance to do the controls. In addition, if you have other lights in your facility that you're not ready to upgrade, you can integrate them with these wireless modules or adapters where you can bring in your existing circuits to the same lighting control system. We did this in a couple of spaces to show how it worked. And again, you can have all of your lights in one facility under one control system. The control system looks like this on the right. You can see it's basically a wall-mounted server with a kiosk. So you have a keyboard and a monitor. This is where you can look at the settings. You can make changes to the controls, and you can get a whole bunch of data and dashboards to see the results and see how things work. So again, very easy to use, a simple interface. You can log in, it has security, it has passwords, all that kind of stuff. So again, it worked very well, and it's self-contained. So one of these per facility. As far as the lighting design process goes, typically you want to start with the UFC, Unified Facilities Criteria document that for interior and exterior lighting systems. This document specifies the illumination targets for each type of facility. Typically, it's between 5 and 60 foot candles, and this will tell you what your target is and how bright your lights need to be. In addition, there are other specs like color temperature and lighting quality measured by color rendering index, things like that that you'll want to know about before you spec your lights. Typically, the retrofits are 1-for-1 replacements. So again, the design is usually not that hard. And normally you want to do photometric calculations to make sure you hit those brightness targets. You can either hire a lighting designer to do that, or in many cases, the lighting vendor will do these for you. In our case, we had a full service lighting vendor, and as part of their sales process, they would do these calculations and create maps and do all this work up front. So ask your lighting vendor if that's an option, and you might save a lot of time. As far as this project goes, having never done a lighting project, the installation was probably the easiest part of the whole project. So once you've ordered your lights, the installation is very straightforward. It's almost no different than a regular lighting install. The electricians would go up to the ceiling, take out the old lights, wire in the new lights. Oftentimes they would reuse the existing mounting hardware or have some very minimal mounting effort. And typically could do it in about 15 or 20 minutes per fixture in install time. So again, very straightforward. The only real difference is we asked the electricians to track the fixtures using barcode stickers that came on the fixtures. When they would install them, you put them on a map, and this just speeds up the commissioning process later on. It's not necessary, but it helps cut down on time later on. They had no problem with that. Apart from that, again, they just had to mount those gateways on the ceiling, run some Ethernet cable, and nothing out of the ordinary. So the install was pretty easy, and you shouldn't be afraid of that. As far as the commissioning goes, again, you don't need to be an expert in control systems or lighting systems to get this stuff commissioned. In our case, the vendor provided this as a service. It was a line item based on the number of fixtures you had in your facility. It took about 1 day per facility to do the commissioning. And the steps typically involve creating a map file where you assign lights to different zones or groups. You add the lights to the network and update the firmware. You can tune the brightness to match a target. So you can measure the brightness when the lights are on and dial it in the settings. And then if you want, you can calibrate the sensors for daylight harvesting. This was a fully automatic process that takes about an hour. And after that, you can turn on the occupancy and daylight controls and then test that everything's working. Again, this took about a day per facility that we had, and it was very straightforward. But getting into the buildings, we did a full lighting system retrofit for 3 facilities covering about 200,000 square feet. So some big spaces and really interesting cases here. On the left was an aircraft hangar used to maintain C-5 aircraft. These are pretty big airplanes that are used in the military. This was about a 9-story ceiling, so a little bit of a challenging application. The next case was a supply warehouse that had a couple of different areas, a shipping receiving area, some storage area, and a shop, and then a fitness center, which had a basketball court, racquetball court, and then some adjacent troffer low bay spaces for fitness rooms and office space as well. So if you check out our report on the ESTCP website, you'll get to find more information on all of this. We'll start here with the warehouse. This was lit by fluorescent lights. Many of you in the military will have seen buildings like this where the lighting is just very inadequate. So here the lights are all on. This is during the daytime, and it was borderline unsafe. The folks in the facility reported using flashlights to find parts with the lights on. It was really not a good place to work. So a very challenging case, and they had no plans to make any improvements or change the lights before this project. After we replaced with LEDs, if you've ever done an LED retrofit project, it really just transformed the space. So we added 176 LED fixtures, got rid of all the fluorescence. We were about 6 times brighter now, and we met the UFC target. And so now you have a much better, safer work environment. So before we talk about energy savings, you want to meet the spec, you want to be able to carry out the mission, and that comes first. Separate from that, we enabled occupancy controls. And again, in conventional systems where you use hardwired controls, you're very limited in what you can do. You basically, tie circuits together and put a sensor on the ceiling and hope for the best. And I think many people have been in a room where the lights turn off and you're waving your arms around trying to catch the attention of a sensor that's in the corner of a room, and it doesn't do a good job. So that can be very frustrating. In contrast, with these wireless controls, you can kind of set them up however you want, and you can change them after the fact. So on the left, you start by organizing the fixtures into groups or zones on the map file. So it's all visual. You could see what's what. And so in addition to that, you can set a target brightness level for the inactive and active states. So when no one's around, we had the lights dim down to 5% brightness. And then in the active state, we went up to 80%. So it's 80% instead of 100% because the lights were too bright to begin with. So that's where we're getting the trim savings. And then finally, the delay here on the right, you can set how long it takes before the lights will dim down. And here we went between 5 and 10 minutes, depending on the area. So we went pretty generous with these delays. We didn't want to cause too much interference. You can actually make a mistake by making this too aggressive, and then people will complain, and then eventually people will disable the controls. So you might want to start more gentle, and then you can get more aggressive over time. But if you're too aggressive, folks will complain. So again, very simple to set up. That's really the main message here. The interface is easy to use, and if you want to make changes, it's just a couple buttons and you're done. And the other piece on occupancy control is the coordination. So you can tie lights together into groups or zones and have them turn on as a group when a trigger fixture sensors motion. So you can define any fixtures as trigger fixtures. Here's an example in a warehouse aisle where you would set up a trigger at either end of the aisle. And so when you walk by the aisle, the whole aisle will light up. This is good for safety. And if you're driving a forklift, you want all the lights to kind of come on at once. And the response time was pretty quick. So the lights would come on within a couple of seconds. And so again, worked very well and is a really good function to have. Changing gears to the aircraft hangar. Similar case here, not quite as bad, but it was dark and shadowy here. If you look all the way across the hangar, you could barely see in the shadows what was there. These were metal halide fixtures. And the drawback with these is they take about 10 minutes to warm up or turn on after they've been on. So as a result, they always had to keep the lights on during the day. They would keep at least half of the lights on in case they needed to do work or bring a plane in or whatever. So again, the LEDs respond instantaneously. And so you can do a lot more with controls there. In the after case, we installed 100 LED fixtures. These were 2 to 3 times brighter and a much better and safer work environment. And with the controls here, we enabled occupancy and the daylight harvesting that we talked about before. Even with the 90-foot ceilings, the sensors had no problem seeing the floor and responding in tune with that. So, the only thing you need to know is to spec the right kind of sensor. They have a plastic mask that you install that gives it a greater range on the sensor. So make sure if you're doing this that you ask the vendor about that before you install the lights. Daylight harvesting, we got about 13% savings on average. This is where the lights dim in response to the available daylight. Again, this hangar had no windows, but it had a large bay at either end that could open these large bay doors. When they're open, even just a little, a whole bunch of light floods into the space and the lights don't have to work as hard. On the graph on the left here, I'll point out this red area represents the savings due to daylight harvesting. So during the daytime on these weekdays, those doors were open and you can see the dip in consumption and the energy savings that goes along with that. So again, we got 13% on average. On the best day, we got something like 29%. And this is really just a function of how many hours a day these doors are open. And again, this is Massachusetts climate. If you're in different areas that are sunnier, you can expect to get anywhere from 13, 20, maybe even 30% savings from daylight harvesting. And again, it's just a checkbox to turn this on and you don't have to do anything after that. To see this in action, this is the same shot, the same picture underexposed, and this shows the lights dimming in a horseshoe pattern. So all of these red arrows point to the lights dimming in response to the daylight near that open door. And then if you go further into the hangar bay, those lights are more or less at full brightness. So again, all the response happens automatically. And because you have a sensor on every fixture, you get a very uniform light on the floor and you would never know that the lights were doing anything special. So again, it worked very well. And this is a lot better than most hardwired systems where you might have only one daylight sensor per zone. If something goes wrong with that sensor, then your lights are out of commission for a long time. Here, if one of the sensors goes bad, it's not a big deal because every fixture has its own sensor built in. So that more or less covers the controls, but what impact does that have on power and energy? So here, we'll show you a couple of scenarios. This is based on a year's worth of data in the before and after scenarios. So we'll start on the left. In the baseline, we had metal halide fixtures, and in the black, this is as found. So remember, the as found condition was too dark. So we made an adjustment, which is basically a linear scaling factor to get this brightness adjusted baseline. So if we had more of the same lights in order to meet the UFC target, we would be up here around 80 kilowatts to 100 kilowatts of power on average for a typical week. And you can see the weekly patterns that we observed in the study. And then if we go over to LED only retrofit, we're getting something like 76% savings by switching to LEDs. So huge improvement on, as far as the power goes from going to LEDs. But then when you layer in the controls, the daylight harvesting, the trim, and the occupancy control, we got all the way to about 89% savings. So you can save a lot more by adding in these automated controls, and it's extremely effective. So again, a lot of the time the hangar is not in use, or people come and go during the day. So there's a huge opportunity to dim the lights and get a ton of savings there. So you'll see more of these in the final report once it's published, but this gives you an impression of where the savings are coming from. There's another misconception that controls have to be very expensive or they're going to cost a lot more. And part of that is true, that the hardware is a little more expensive than if you have lights with controls built in, it will cost a little more. But in terms of the installed cost, it's not that much more, or it's not out of the ordinary expensive. We were able to do the whole project for all 3 facilities for less than $2 a square foot. And so I think this is a very good achievable target, and it will vary depending on the lighting density. So you do better in high bay spaces than you do in high density areas like the gym, but overall the project was very cost effective, and you can see here in our project most of the costs came from the lighting hardware, and only about a quarter of the costs came from the electrician labor and whatnot. But again, your mileage may vary. It'll depend on who's doing the work and things like that. I will say that, one insider tip is kind of don't tell the electricians that you're doing anything too fancy. Like don't make them responsible for setting up your controls, because then they'll price in a whole bunch of risk premium and then it might be very expensive. If they see the project and it just looks like any other lighting retrofit, you're more likely to get a reasonable price. And I think that really helped us out in this case. Okay, and then what about the cost savings? So again, here we got 89% savings in the hangar, close to 70% in the warehouse, and about 80% in the gymnasium. Now that's the combined savings from the LED and the controls. So overall, we're looking at about $100,000 a year in savings relative to that adjusted baseline. And so again, outstanding performance, cost and performance. You can, again, dig into this more in the final report, but relatively fast paybacks for the project. The other thing I'll say is if you have some areas like parts of the gym that maybe weren't cost effective on their own, if you build them into a larger project, the entire project can be cost effective and sort of pay for the savings in some of those other adjacent areas. So keep that in mind as well. These high bay spaces can pay for some of these office spaces through the savings. And I guess here, just to sum up, with integrated LED lighting controls, they were super highly effective. We were able to deliver more light, a lot more light, with less energy, cost-effective installed costs, and relatively fast payback period for the entire project. Overall, the users were overwhelmingly satisfied, both with the LEDs and the control strategies. We did user surveys and we got feedback. The initial feedback in some of the areas was that it was too bright, and so we were able to trim the lights down even further. And overall, the system was very well accepted. So as the key takeaway, don't be afraid of lighting controls. These can really make a big difference and provide a lot of flexibility to your spaces. So to sum up the benefits to the DoD, you can have brighter and safer buildings, cost-effective savings, flexible controls, and kind of at the high level, the DoD, we estimate, spends an estimated $400 million or more to light their facilities. Typically, this is about 12% of facility electricity consumption. So there's a huge potential to save a lot more using these LEDs and advanced controls. And I encourage all of you to take a serious look at this in your lighting projects. So with that, I will conclude. There's the ESTCP website for the project, and you can check it out. And now would be a great time for some questions and answers.
Thank you so much, Brian. As a reminder for our audience, please submit your questions by using the Q&A box on your screen. Let's see, the first question that has come in, where did you face the most pushback in deploying the system? And how did you get past that?
Yeah, so that's a really good question. When we were having our initial design meetings at the base, we had to talk to a whole lot of people from different disciplines. So we spoke with end users, we spoke with civil engineers, we spoke with construction folks, and we spoke with the IT and cybersecurity folks. And everybody had some different concern or some reason why we couldn't do this. There's no way you can have wireless controls in a hangar. There's no way you can have wireless controls near a flight line. And so there was a lot of resistance to some of these things. And so I think a big part of this was being patient with all that, and sort of acknowledging that people don't fully understand the technology at first, and it might take a while to get them around to understanding what it is, what you want to do, and how it works, and all that stuff. So there was some skepticism, and I think the key was just providing information and letting everybody say no first, and then kind of working through their objections eventually to get them on board. So once they fully understood what we were doing and what it was, a lot of the things were relatively easy to overcome. And the wireless example was a really good one. Once we worked with the Spectrum office at the base, they wanted some information. We gave them basically the FCC IDs of all the wireless radios used in the project, and they were able to look up the frequency and all that stuff. And they said, "Oh yeah, no problem. This is kind of like Wi-Fi, no big deal." And then we got the approval to go ahead. So again, some of this, people who work on military construction know about this, but just be patient with everyone and help them understand how the technology works and what it does.
Great, thank you. And what kind of spaces or buildings work best for automated lighting controls, and where might you want to avoid using lighting controls?
Yeah, so that's another good question, because obviously you can do a whole lot and provide a lot of flexibility and savings, but this kind of system might be overkill if you're just doing a small retrofit in a conference room or part of a building. If you're investing in a whole lighting control platform, you want to make sure you're doing enough facilities to make it cost effective and worthwhile. On the control side, there's a couple things to consider. You get the most savings out of daylight harvesting, obviously, if you have enough windows or enough available daylight. So that's pretty obvious. But for the occupancy controls, you'll do the best there if you have unpredictable schedules. And so the gymnasium was a really good example of that, because they operated that facility 24/7. And sometimes people would play basketball at 3 a.m., but not every night. And so a lot of the time you can turn off those lights automatically and save a whole lot. If you have very predictable office hours and people are always around, you might not get as much savings in that kind of a situation. So again, same with the warehouse was a really good application, because people are coming and going in the warehouse all day, but you might have a big hour-long stretches where nobody goes in for 5 or 6 hours at a time. So the lights can stay dim for most of the day, and you get a whole lot of savings that way. So again, keep all that in mind. But with a platform like this, you have a whole lot of flexibility in terms of how you get the controls and how you set it up. So
fantastic. This next question is from Dominion Energy. Are there any cybersecurity concerns for the systems you've installed?
Yeah, that's a great question, and I could probably spend another hour on that topic. But very briefly, we did need to go through some cybersecurity documentation process and things like that. So DoD has their risk management framework process and their authority to operate process, and we depending on what service you're working with, they might have templates or things for vendors or contractors to start with. But in our case, there wasn't a ton to do, but there were a few key steps. So one is you need a system inventory. So you need to keep track of all your fixtures and serial numbers and where they go and all that stuff. Much of that information can come right from the platform. The second piece is this system we did not integrate it with any DoD control system. So it was fully standalone, did not connect to the internet. So that greatly reduced the boundary or the things that you need to worry about. In addition, I guess part of the cybersecurity framework is keeping track of users and passwords and who gets in and who has what access. And so you'll have to work closely with the base on all of those elements. But really the key is setting up the system using the vendor's best security practices. So you look at their manual, you turn on encryption on the network, a couple things like that. But it wasn't anything outlandish. And then the final piece of that is making sure there's a clear process for doing maintenance or maintaining the system. So you want to make sure that there's a clear transition, or some, how do you replace a fixture if it goes bad, and how do you integrate it back into the system? Who does it? What are the procedures for that? So we did develop some basic SOPs or standard operating procedures for that. And in addition, if there's any other issues, they can contact the vendor and they'll come out, and for a fee, they could come out and do some of that work. So there's a lot of things to think about, but it didn't stop us from moving ahead.
Great, thank you so much. This next question has to do with the control system. What happens should the control system network fail? How can you configure the system to minimize impacts during network outages?
Right. Yeah. And so this actually ties into the previous one of the previous questions. One of the biggest objections we got during the design phase was, what happens when this thing, the controls fail, or when it breaks? How do you override the system? People were very concerned about that, and rightly so. You don't want the lights to go crazy, and you need to be able to turn them on or turn them off at a moment's notice. So there were a couple things that helped us with that. The first is the way this control system works is, suppose that lighting control appliance, that server, blows up or breaks or whatever, or all the networks gets disconnected, or the wires to those gateways get disconnected. The lights have enough smarts on board where they will keep doing what they were last told to do. So if their command was to have a 5-minute delay and to dim after 5 minutes and go to 80% brightness, every light will remember that and continue doing that independently. So the only function you lose is basically the grouping or the zoning that you had before, and the coordination. So the lights have a very resilient failure mode, and as long as you program the lights in a way that it allows them to come back on, you won't have any issue in the space. So I think once we explained that or had that figured out, it wasn't much of a problem. The other piece to that earlier objection is like, oh, what happens if this is too complicated or doesn't work right? We reminded everybody that these are just LEDs. So if eventually people get frustrated or decide that they can't maintain the system any longer, they could disable all the controls, and now you just have regular LEDs. And I think that made people a lot more comfortable with trying out a new technology. It's, you're not stuck with, you don't have to use these controls if you don't want to. And, if you can't get a new controls appliance, you have a way to reprogram the lights so that they don't use any of the smart controls at all. And again, I think that helped us get over some of those barriers.
Fantastic. Thank you so much. How do you balance energy savings with user experience? And what issues, if any, did you encounter with the control operation?
Yeah, so yeah, that also ties into a previous question. So the as far as, I think we hinted on this earlier, but basically you don't want to be too aggressive out of the gate. This is what we were saying. You want savings, but you don't want to make it uncomfortable, or you don't want it to impact the mission. So if the lights are turning off every 30 seconds, you're going to start disrupting people, and they're going to get annoyed, and they're going to find a way to defeat or disable the controls. So again, most of our spaces, we went with a 5-minute or 10-minute timeout, and we had the lights dim to 5 or 10% in the dim state. We did get feedback from some users that they wanted to go full dark, and so we gave them a keypad button that would do that for them. But for the most part, you get most of the savings, and then the occupants are still happy and satisfied. So I think it's important to strike that balance and not to push too far on the energy side. And then in terms of what happens when the system fails, so we did have an instance where in the warehouse, somebody inadvertently killed power to the lighting control server. So it was about 2 months that the server was offline, and we went back in to collect some data, and we asked the people in the facility, how are the lights working? Is everything okay? And nobody had even noticed that the server was down or that the lights were working improperly. So, again, we lost the zone coordination, but the lights were working independently, and everyone in the facility was fine with that. I think it's because the lights were so much brighter than they were before that, nobody gave it a second thought. So again, if you have a good resilient failure mode set up, it's really a non-issue when the control system goes down.
Wonderful. And then one last question before we move on to John's presentation. Do you have any follow-on phases planned for this project, or is your demonstration complete?
Yeah, so right now our final report is in the review phase, and so that should be published probably later this year. There is a follow-on technology transfer project that's being led by Slipstream. They had another similar connected lighting demonstration, and they are developing a learning platform that will host hour-long training videos, including some on this topic that go in a lot more detail as far as different lighting control strategies and applications and all of that as a continuous learning platform. So all of that is underway, and some of those presentations are in review. So keep a lookout for that, and there will be some more resources on that available.
Fantastic. Well, thank you so much. We'll get back to any unanswered questions towards the end of the webinar. For now, I'm going to go ahead and introduce our second speaker today. Mr. John Schlechter is the CEO of the Mechanic Technology Company in Grand Rapids, Michigan. John founded Mechanic in 2007, working in partnership with Fraunhofer USA to develop insulation and energy management systems for fenestration. Mechanic has since grown into a multinational business with R&D operations in both North America and Europe. John himself is currently serving as a PI for a partnership project funded by ARPA-E and ESTCP on demonstrating the energy savings of Mechanic's window energy management system, which you're going to be hearing about today. Finally, he further developed this technology for DoD use with blast mitigation through a contract with the U.S. Army Corps of Engineers U.S. Army Corps of Engineers ERDC, or Engineer Research and Development Center, and he conducted the blast testing at ERDC's Geotechnical and Structural Lab in Vicksburg, Mississippi. John, we're delighted to have you. Please proceed. John, you may be on mute. You are on mute. Can you please unmute yourself?
There you go. Thank you. The mute button disappeared from my screen. I just found it. So yes. I apologize for that. Thank you. Yeah, I'm John Schlechter. I'm the president of Mackinac Technology. And as Rula said, we were founded in 2007, and we've worked very closely with the Fraunhofer research groups here in Michigan and in Boston. And we also have a subsidiary in Germany where we partner with Fraunhofer research groups there as well. And I'm here to talk about our window energy management systems technology. We use the acronym WEMS because DoD likes WEMS or likes acronyms, and so it's much easier to say WEMS than the full word. And we're here to solve the problem of energy loss through windows. So windows are an important architectural feature. They help with daylighting. They also help with feelings of well-being and health and happiness. Everybody wants an office with a window, but as any energy facility manager can tell you, windows are a huge problem for energy efficiency. They're responsible for as much as 80% of the heating and cooling energy loss through a building envelope. So the traditional approach to dealing with a poor performing window is to take out the old window and throw it in a landfill and install a new window. And there are products out there that do improve energy performance over older windows. Double pane windows, IGUs, are 2 panes of glass with a spacer that are sealed. There's typically a low E coating, a silver-based low E coating on the inside. And the cavity is filled with argon gas or krypton gas. More recently, triple pane IGUs have come on the market, and thin triple IGUs are window units where there are 2 pieces of thicker glass on the outside and then a very thin piece of glass in the middle. And that glass is very similar to the glass that's on your smartphone screen. Vacuum insulated glazing products are starting to come on the market. And then there's electrochromic coatings, which darken the window. Limitations with replacement glazing are that it's expensive. Energy contracting companies rarely, if ever, will willingly remove existing windows, no matter how inefficient they are, and replace them with new windows because the cost of installing the new windows is too high and the energy savings is too low to make a good business case for them for that to do that. So often in energy performance contracts, the windows stay there even though they've been identified as a problem for energy efficiency. If you need force protection features on the replacement windows, that can add to the cost of the new window. And it's important to understand that IGUs have a 100% failure rate. It's just a matter of time, whether it's 10 years or 20 years or however long it is, those seals will eventually begin to leak. And then the gas or vacuum that's on the inside will degrade, and that window will not perform as well as it did when it was first installed, and will likely need to be replaced again. Secondary glazing or secondary windows is just a fancy word for storm windows. Storm windows have been around for many, many years, and they've always worked well. But this technology, this sector has had a lot of activity in the last decade or so, developing new approaches to make secondary windows a much more effective and viable technology for improving energy performance of windows. The Department of Energy established the Attachments Energy Rating Council, and attachments, secondary windows are a subcategory under the broader attachments category. Attachments include shades and curtains and awnings and anything that's attached to a window that changes its energy behavior. And secondary windows are a subset underneath the broader attachments category. The goal of AERC is to establish a standardized rating system so that people who are looking at different types of attachment products can understand basically apples to apples how this product performs compared to that product. AERC is recently is now being incorporated under the Partnership for Advanced Window Solutions, and PAWS includes new windows, replacement windows, as well as the secondary windows. So the entire window sector will be under the auspices of one association. Advantages for secondary glazing is that you can leave the existing glass there. There's no need to throw it into landfill. You don't have construction. There's no dismantling of the existing window, which leads to less disruption of the occupants, and also can lower costs. And it can lower costs by enough to potentially make secondary glazing a viable option for energy service companies, whereas replacing the windows is not. And with Mackinac WEMS products, we have longer life cycles than you do with a replacement window because we do not have a sealed system. It's not filled with gas. The coatings that we use for low E are stable when exposed to the air. They will not corrode. And the materials are very durable and resilient. We don't know for sure how long they can last, but we do know that units with similar materials have been in the field for over 40 years with no degradation of property. So we're very hopeful that this will outlive me anyway. So what makes our product unique is that we don't use any glass at all in the window attachment. You can see on the right-hand side is an existing double pane window, and on the left-hand side is the WEMS unit. The panes are made out of a proprietary polymer technology that I'll talk about in a little bit. The frame is designed to be porous. So when sun comes and warms up the air temperature inside the system, the air will expand by quite a bit, and that pressure will actually force air out through the porous feature in the frame, which equalizes the pressure. And then when the temperatures cool down and the air contracts, it'll pull it back in and equalize the pressure again. This helps with durability, and it also helps mitigate moisture condensation on the existing glass, which is a a chronic problem with window attachment products. We apply low E coatings to both sides of each pane in the WEMS unit. So this double pane WEMS unit has 4 low E coatings. What we're doing is following the principles of multi-layer insulation that are commonly used in spacecraft. One of our early scientists came from NASA and joined us, and that's where this basic concept came out of that relationship. And it's to understand how heat transfer through windows works. 2/3 of the heat transfer is by means of electromagnetic energy, and 1/3 is often attributable to conduction or convection. So if we attenuate the infrared heat transfer, we're left with conduction and convection. And in our products, we have 2 gaps here of stagnant air, which has a really good insulation value similar to styrofoam. And so that's how we're able to get a really good insulation performance without needing to use argon or inert gas. But if we were going to, when we started doing this, we realized that we needed to develop a more transparent low E coating. Silver-based coatings, like the one shown here on the left, are great. They're effective. They're used in all kinds of window products and window film products, but they only let through about 60% of visible light per layer. And if we were to do that times 4, we would get a really dark unit, and people don't like that. So we developed a low E coating with our partners at Fraunhofer that transmits more than 90% of visible light. And we put that on all surfaces of a double pane system, and we get greater than 80% light transmittance, which is what we were looking for. As I said before, the secondary window category is very dynamic. There are many of the companies that already make glass IGU products are now expanding into making window attachment products. They can use the same basic materials, same manufacturing process, and they make a sealed, a double pane, or sometimes thin triple pane unit, and then that becomes the secondary window. There are polymer products out there. These use standard materials like acrylic or polycarbonate. Some use polyolefin or PVC, and those products typically don't have low E coatings, which limits their energy performance. And many of these polymers are flammable, which we were told by DoD that we were not going to be able to put any flammable units inside their buildings, and so we went to a different route. And the technology that we used for our window panes is an architectural membrane material. It's widely used already in the building industry. Like the water cube is the swimming pools in the Beijing that they had for the Olympics a few years ago. They're often football domes. Football stadiums are made of this material. It's very tough. It's very durable. It doesn't yellow. It's 1% the weight of glass, less than 1% in some cases, but it is hazy. So we developed a process to make this hazy material clear, and that way we were able to use it in our product. Another feature that's attractive is that these materials are non-flammable. They are self-extinguishing, so it will not burn when exposed to a flame. And we did really well on blast testing at the ERDIC laboratory in Vicksburg, Mississippi. Here they had a double pane glass window, and we put a double pane WEMS unit over top of it, and they blew off blast force on the outside, and it shattered the glass, and the glass came in and got trapped by the film and then got sent back outside. So in these tests, none of the glass came inside the room, which was really quite exciting for us when we saw that happen. So comparing performance of replacement windows with secondary windows like our WEMS units, you can see that a double pane WEMS unit installed in front of a single pane glass window has about the same performance as a triple pane window with low E coatings, and that makes sense. Window physics being what it is, if you have 3 panes of window, you're going to get a certain level of performance. And so whether you install a new triple pane window or you install a double pane WEMS unit against a single pane of glass, you get the same performance. We can also install products, WEMS units with 1 pane or more panes if we want. The energy performance goes up linearly by adding panes. So we originally got our funding from ARPA-E back in 2016 under the ARPA-E Open program, and it developed the basic technologies that became this product. And then we got follow-on funding from the Army Corps of Engineers, ERDIC, Construction Engineering Research Lab in Champaign, to develop this for DoD app installations. And we are now working on an ARPA-E ESTCP program. It's a program, a partnership between ARPA-E and DoD to demonstrate ARPA-E funded technologies in DoD facilities. And we are about halfway through that project now. The project was to install WEMS units in the Air National Guard Base and Selfridge Air National Guard Base in Mount Clemens, Michigan. This was a fairly short installation, only lasting a few months. It was mainly to test out measurements, find out what we didn't know. There's a lot that happens at a window. There's a lot of sun coming in, moisture condensation, lots of things going on there, and how to measure effectively what's happening and how to do the installation was a learning curve for us. And so we did a lot of learning at Selfridge. And then we went to the United States Air Force Academy in Colorado Springs, where we installed units in their facility and monitored their performance for a year. And that year just finished up this spring, and we have the data from that, and we're preparing a report of that data. And while we were there, we also installed some product at the Denver Federal Center as part of the GSA Green Proving Ground program. The objective of the program was to decrease window energy losses by 70% or more by increasing the R value of the existing window by R5. And I apologize to the people who are window experts. I'm using R because a lot more people understand what R value means instead of U value. So please bear with me here. But by increasing the insulation value of the existing window, the goal was to save $1.25 to $1.50 per square foot per year of window area. And we achieved our objectives. We increased the R value of the existing window. The existing windows at the Air Force Academy are double pane with a low E coating already in them. So they already perform well. And so we added R5.7 to that existing double pane window. And we did that without significantly reducing the solar heat gain, which is important in colder climates. And we had a good visible light transmittance. Again, keep in mind that this is 4 panes of window, 2 panes of glass with a low E coating in there, and then the double pane WEMS unit. And we're still at 0.66 in terms of visible light transmittance. So it was a very good, successful installation. This is what the building looks like. It's a beautiful site for demonstrating window technologies. They have a lot of windows facing all 4 directions. This building was built in the 1950s. And so it wasn't really made to be energy efficient. So it is an interesting challenge for them to try to achieve energy efficiency goals. We've had a really good working relationship with the Air Force Academy for many, many years. We executed a crater with them, I think back in 2011 or so already. So they've been a great partner, and we really appreciate their support for this project. Here's the unit being installed. You can see it took 2 people less than 5 minutes once they took it out of the box. And for any window attachment product, any secondary window product, it's important to measure the existing window first, because even though they look like they're square, they may not be. After time, things settle, things move. They're not always exactly the same size, and any fit and finish that happens on the job site dramatically increases your installed cost. So you have to measure each window individually and carefully make the unit so that it fits that specific window. And then when it arrives at the site, you install that unit in the window it was designed for. And if that all goes right, it slips into place and takes less than 5 minutes to install, which is what we achieved. And here you can see that the left-hand side is the control window, had no WEMS unit on it at all, and the right-hand side is the product with the WEMS unit. We had to cut it in half because our coating machine can only coat 5 feet by 10 feet pieces, and these windows were bigger than that, so we had to put this little spacer bar in between and do 2 halves. When we're in full-scale production, we'll be able to make units that are the full size of the existing window here without needing to do this spacer bar. Our friends at NREL were very generous with their time and helped us setting up the measurement system. It was important that we got data that was going to be acceptable by people in the industry, and so ARPA-E supported us in bringing NREL on board so that they would confirm the measurement systems and the data gathering system that we used. And as you can see, we had lots of ways of measuring lots of things going on here at the windows. And then this was reported on a dashboard. This was not done for the internet because of cybersecurity issues. We did this via cell phone connection, continuous cell phone connection, and it worked really well. We got data in real time, and then we could also go back and look at historical data and analyze what's going on. One thing I'd like to show you is on the bottom chart, that blue line at the top is the heat flux, the heat transfer through that window of the control window. And you can see it has lots of peaks and valleys depending on what was going on the outside, the exterior weather. And the bottom line is the window right next to it with the WEMS unit. And that is a much flatter line. It doesn't have the peaks and valleys, and there's much less heat flow going through that window. And if you're thinking about it from a holistic building energy standpoint, and you're thinking that you need to someday replace an HVAC system or maybe change over to heat pumps, you're going to need to size that new system. If you're just having a double pane glass window, you're going to have to size that system to fit the peaks of this heat transfer, the heat flux. And if you use WEMS units in front of the window, you could conceivably use a smaller system. We've calculated that it might even be possible in many cases to use about half the capacity, which will help with cap cost and also help with reduce energy costs. So here's the performance data that we got. We had model data and actual measured data. The existing window was a little over R2, R2.2, which is really standard for a double pane window with one low E coating. And then when we added to that double pane window a double pane WEMS unit, we got our values over 8. And that reduced the energy loss by 75% in one case and 73% according to the model. Depending on which day it was, these R values tended to vary based on wind speeds and so on. But this is an average for that first installation. And then looking at other products out there, examples of other secondary window products are like Windsert or the Quanta panel, and there are others, Thermalite and so on. And they're all going to be in about the same price point, $15 to $20 to $25 per square foot, depending on what you get. So these products are all similarly priced. And as you can see, compared to a double pane glass or a triple pane glass replacement window, the installed costs are consistently much less. So instead of $20 per square foot, you're going to have to spend somewhere in $40 to $50 per square foot by the time you get it installed. So on a big building, that can become a big number, that difference. So the effect on reducing carbon emissions, if you were to install WEMS units on a large office building, according to DOE's reference book for buildings. It has the same effect on CO2 emissions as changing 820 gasoline-powered vehicles to electric vehicles. That's assuming, of course, that the electricity is generated with carbon neutral technologies. The same effect as installing about half of a wind turbine or planting 1 million urban trees. And of course, if you do all of the above, you really do start to have an impact on carbon emissions. So we were successful. We did decrease energy loss by about 70%. And we did save the $1.50 per square foot of window area. Now, keep in mind that you need to model every individual building to anticipate what the energy savings is going to be, depending on your energy source, where your building is located, how many windows you have, what their orientation is. Those all are going to affect this calculation. So don't take this as a number that you're going to necessarily see in your building. It could be higher by quite a bit, or it could be lower. It just all depends, and we can certainly help with the modeling if you'd like to consider this for for a building. And the decrease in energy loss is just for phase one, the technology we tested in phase one of our ESTCP demonstration project, and that's the base SWEMS unit with just 2 panes and a spacer and a frame, and that's it. We do have other features that can be added to the base product that we will be demonstrating during phase 2 of our ESTCP project. And one of those optional features is shading, dynamic shading. It's a louver system, and we have a light reflecting, light redirecting technology that can direct daylighting inside the room against the ceiling to help improve daylighting. And then it also, if you angle it facing more outward, then it can eliminate solar heat gain as effectively as an electrochromic window. And so this brings into play some potential for synergies with the controls technologies that Brian described earlier, where if you can have the lighting inside being controlled and also the dynamic shading and light redirection for daylight harvesting and reduction of solar heat gain, it's possible to have a much more effective impact and even greater savings using those sorts of technologies in combination than you can with either one of them all by themselves. So the benefits to DoD are that you can reduce your energy demand in a facility without needing to replace existing windows. And we can also add some force protection. We're not certified for that yet. We do need to go through some more testing with the Army to claim that we can be used for this purpose, but that it's a potential then, and we are working on getting that approval. You can also improve operational capabilities and maximize fiscal resources, or reducing operating costs and capex for HVAC and other types of equipment. So that's it.
Thank you, John, for a great presentation. We received a number of questions, and we'll go through those now. Can the units that you described be used over operable windows that open and close?
Yes. One advantage of the lighter weight material is that for like casement windows that crank open, we can attach them right to the frame of that casement window without damaging the hardware, and they can open and close no problem. For other windows like double hung windows, we have hinged mechanisms that we can use to open the unit and then also open the window. And we even developed a pocket door type system for one of our customers in Europe that had a hotel, and they wanted this in front of their sliding glass doors. So there's a lot of possibilities for that. Yes.
Fantastic, thank you. The next question has to do with the way these are installed. Are they only installed on the inside, or can they also be installed on the outside of an existing window?
Yeah, that's a good question. They can be installed either on the inside or the outside. We've only demonstrated the inside installation so far on the ESTCP project, but we have done some outside installations because of the membrane material we use is totally suitable for outside installation. And when we start doing dynamic shading, especially trying to reduce solar heat gain, it's much better in many cases to have that all on the outside of the window to keep the heat from coming in and leaving it outside before you even, once you get inside the glass, it's kind of hard to get rid of it. So, yeah.
Great, thank you. Next question, could your secondary window units also be used as primary windows for portable structures?
Yes, we had some discussion with the Army Corps of Engineers about using this for forward operating bases. It'd be less weight to try to transport to the front line than using glass. This is something that we've developed some concepts for, but we haven't actually tested yet. We're hoping that at some point to have conversations and get some funding to do that development. But that's definitely something that's potential.
Thank you. In the event that one of the panes gets damaged, can it be replaced without replacing the entire unit?
Yes. So these things are assembled in such a way that we can take a damaged pane out. We would either take it out and then ship the frame back to get a new film put across it, or we can just ship a new complete film with a frame and just take the unit apart in the window in the site and then stick it back in without having to take the whole thing down.
Thank you. And along the lines of what we relayed to Brian as a question, is there a next phase for this project?
Yes. Phase 2 is going to be to install units at the Air Force Academy that have dynamic shading in them, and to measure the impact on lighting and also on solar heat gain on a south-facing window where there's quite a bit of problem with solar heating going on. And we hope to start that. We did have our facility destroyed by a tornado in Mississippi in March, and so we're a little bit on hold now as we dig out from the rubble and start setting things back up. So the ESTCP project is on hold temporarily, and we hope to get that going here soon.
Wonderful. No more questions have come in, and you've done a great job of answering the 5 that we relayed to you. So we're going to go ahead and wrap up, and thank you both again for a phenomenal webinar. Our next webinar is on Thursday, July 27. The topic will focus on DoD-funded research efforts to improve natural resource management by better understanding how disturbance and climate variability impact DoD lands. The webinar will feature 2 speakers, Dr. Tom Anderson from Southern Illinois University and Dr. Elizabeth Crone from the University of California in Davis. Registration is open, so please visit the SERDP and ESTCP webinar webpage to register for this and other webinars to the beginning of next year. And note that the next EW webinar will actually be in early October. Registration is also available for that webinar. Before we conclude, to echo what Tim said, I'd like to remind you that both the audio and a copy of the presentation of today's session will be archived on our webinar webpage in case you would like to refer to them in the future. We would appreciate it at this time if you can please take a moment to complete the survey that will pop up on your screen. This concludes today's webcast. Thank you so much for your participation.